According to the National Electrical Code, it is generally permissible to install a panel board in a restroom. However, there are several requirements and considerations that must be followed. NEC Section 210.23 D1 states that panel boards shall not be located in bathrooms that contain a bathtub or shower if the bathtub or shower has any exposed water supply or drain pipes. NEC Section 406.9 C states that panel boards in wet or damp locations shall be installed in a weatherproof enclosure or otherwise protected from moisture. In addition to these specific code requirements, there are also several additional considerations that should be taken into account when installing a panel board in a restroom. Firstly, ventilation. The restroom should have adequate ventilation to prevent moisture buildup and corrosion. Secondly, enclosure. The panel board should be enclosed in a weatherproof or moisture-resistant enclosure. Thirdly, location. The panel board should be located away from sources of water, such as sinks, showers, or tubs. Fourthly, accessibility. The panel board should be easily accessible for inspection and maintenance. There are some exceptions to the general rule that panel boards cannot be located in bathrooms with bathtubs or showers. Firstly, ground fault circuit interrupter, or GFCI, protection. If the bathtub or shower is protected by a GFCI, the panel board may be installed in the bathroom. Secondly, dedicated branch circuit. If the bathroom does not contain any other appliances or outlets, and the panel board is dedicated to serving only the bathroom, it may be installed in the bathroom. It is important to note that local building codes may have additional requirements or restrictions regarding the installation of panel boards in restrooms. Always check with local code officials for specific details. While it is technically permissible to install a panel board in a restroom per code, it is generally recommended to avoid doing so if possible, as it can introduce potential safety hazards and maintenance issues. Consider locating the panel board in a more accessible and dry location outside of the restroom. Installing a panel board in a restroom requires careful consideration of the National Electrical Code, or NEC, and local building codes. Understanding the specific requirements and exceptions is crucial for ensuring a safe and compliant installation. The primary concern when installing electrical equipment in a restroom is the presence of moisture. Bathrooms are inherently damp environments, and moisture can lead to corrosion of electrical components, increasing the risk of electrical shock and fire. Therefore, the NEC has specific guidelines to minimize these risks. Firstly, NEC Section 210.23 D1 explicitly prohibits the installation of panel boards in bathrooms containing a bathtub or shower with exposed water supply or drain pipes. This regulation aims to prevent direct contact between water and electrical equipment, which could create a hazardous situation. Exposed pipes increase the likelihood of condensation and accidental water splashes, making the presence of a panel board in such locations unsafe. Secondly, NEC Section 406.9 C addresses the broader issue of damp and wet locations. It mandates that panel boards installed in such environments must be housed in weatherproof enclosures or otherwise protected from moisture. Weatherproof enclosures are designed to prevent water from entering and damaging the electrical components inside. This protection is essential to maintain the integrity and safety of the electrical system in a moisture-prone environment. In addition to the NEC requirements, several other factors should be considered to ensure a safe and reliable installation. Ventilation plays a crucial role in mitigating moisture buildup. Proper ventilation helps to remove humid air from the restroom, reducing the risk of condensation and corrosion. Restrooms should have exhaust fans or other ventilation systems that effectively circulate air and maintain a relatively dry environment. The location of the panel board within the restroom is another critical consideration. It should be positioned away from direct sources of water, such as sinks, showers, and tubs. Maintaining a safe distance from water sources minimizes the risk of accidental splashes and water damage. Furthermore, the panel board should be easily accessible for inspection and maintenance. Clear access allows electricians to perform routine checks and repairs without difficulty, ensuring the ongoing safety and functionality of the electrical system. Accessibility also facilitates quick response in case of emergencies, such as electrical faults or overheating. While the NEC generally restricts panel board installations in bathrooms with bathtubs or showers, there are exceptions under specific circumstances. Firstly, if the bathtub or shower is protected by a ground fault circuit interrupter or GFCI, the panel board may be allowed. A GFCI is a safety device that detects ground faults and quickly interrupts the electrical circuit to prevent electrical shock. By providing an additional layer of protection, a GFCI can mitigate some of the risks associated with moisture in the bathroom. Secondly, if the bathroom does not contain any other appliances or outlets and the panel board is dedicated solely to serving the bathroom, it may be permissible. This exception typically applies to small, basic bathrooms with minimal electrical needs. However, it is essential to verify compliance with local codes and obtain approval from electrical inspectors before proceeding with such an installation. Local building codes may impose additional requirements or restrictions on panel board installations in restrooms. These codes can vary depending on the jurisdiction and may reflect local environmental conditions or specific safety concerns. Consulting with local code officials is crucial to ensure full compliance with all applicable regulations. While it is technically possible to install a panel board in a restroom under certain conditions, it is generally advisable to avoid doing so whenever possible. The presence of moisture and the potential for water damage make restrooms inherently risky environments for electrical equipment. Locating the panel board in a more accessible and dry location outside the restroom is a safer and more practical solution. This approach reduces the risk of electrical hazards and simplifies maintenance and repairs. In summary, installing a panel board in a restroom requires careful adherence to the NEC local building codes and best safety practices. Understanding the specific requirements, considering the environmental factors, and prioritizing safety are essential for ensuring a compliant and reliable electrical installation. When in doubt, consulting with a qualified electrician is always recommended to ensure that all work is performed safely and in accordance with applicable regulations. Panel boards, also known as electrical panels or breaker panels, are crucial components in electrical distribution systems. They serve as the central point where electrical circuits are organized and protected by circuit breakers or fuses. These protective devices interrupt the flow of electricity in the event of an overload or short circuit, preventing damage to equipment and reducing the risk of electrical fires. Understanding the function and operation of panel boards is essential for electrical safety and proper system maintenance. Panel boards typically consist of a metal enclosure containing a busbar assembly, circuit breakers, and wiring connections. The busbars are conductive strips that distribute electricity from the main power source to the individual circuits. Circuit breakers are switches that automatically trip and disconnect the circuit when an overcurrent condition is detected. They are designed to protect the wiring and connected devices from damage due to excessive current flow. The wiring connections within the panel board are carefully organized and labeled to ensure proper circuit identification and ease of maintenance. Each circuit is typically designated for specific loads, such as lighting, receptacles, or appliances. The National Electrical Code, or NEC, provides detailed requirements for the design, installation, and maintenance of panel boards. These requirements cover various aspects, including the sizing of conductors, the selection of circuit breakers, and the grounding of the panel board enclosure. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Proper grounding is a critical safety measure for panel boards. Grounding provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. Without proper grounding, fault current can flow through unintended paths such as metal enclosures or equipment, creating a shock hazard. The NEC requires that panel board enclosures be grounded to a grounding electrode system such as a grounding rod or water pipe. The grounding conductor must be properly sized and connected to ensure effective grounding. Regular inspection and maintenance of panel boards are essential for identifying and addressing potential problems before they lead to failures or safety hazards. Inspections should include checking for loose connections, damaged wiring, and corroded components. Circuit breakers should be tested periodically to ensure they are functioning properly. Any signs of overheating, such as discoloration or melting, should be investigated immediately. Maintenance tasks may include tightening connections, replacing damaged components, and cleaning the panel board enclosure. It is important to de-energize the panel board before performing any maintenance work to prevent electrical shock. Working on energized electrical equipment should only be performed by qualified and trained personnel using appropriate safety equipment. The location of a panel board is an important consideration for safety and accessibility. Panel boards should be located in dry, well-ventilated areas where they are easily accessible for inspection and maintenance. They should not be located in damp or wet locations, such as bathrooms or laundry rooms, unless they are specifically designed and rated for such environment. Panel boards should also be protected from physical damage, such as impacts or vibrations. The NEC specifies minimum clearances around panel boards to provide adequate working space for electricians. These clearances ensure that electricians have enough room to safely perform maintenance and repairs. Overloading a panel board can lead to overheating and potential fire hazards. Each panel board has a maximum ampacity rating, which is the amount of current it can safely handle. Exceeding this rating can cause the circuit breakers to trip frequently or, in severe cases, damage the panel board. It is important to properly size the panel board for the expected load and to avoid adding too many circuits or high current devices. When adding new circuits to a panel board, it is essential to ensure that the panel board has sufficient capacity and that the new circuits are properly installed and labeled. Overcrowding the panel board with too many wires or poorly organized connections can create safety hazards and make it difficult to troubleshoot problems. All wiring connections should be made securely and according to the NEC requirements. Arc fault circuit interrupters, or size, are another important safety device that can be installed in panel boards. Size are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults can occur when insulation on wires becomes damaged or when connections become loose. A size trip the circuit when an arc fault is detected, preventing a fire from starting. The NEC requires a size to be installed in certain circuits, such as those serving bedrooms and living rooms. Surge protective devices, or SPDs, can also be installed in panel boards to protect electronic equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic devices, such as computers, televisions, and appliances. SPD divert the surge current to ground, protecting the connected equipment from damage. The NEC recommends the use of SPD in residential and commercial buildings. In summary, panel boards are essential components of electrical distribution systems that require careful design, installation, and maintenance. Compliance with the NEC, proper grounding, regular inspections, and the use of safety devices such as GFCIs, size, and SPD are crucial for ensuring the safety and reliability of electrical systems. When working with panel boards, it is always recommended to consult with a qualified electrician to ensure that all work is performed safely and according to applicable regulations. Electrical safety is paramount when dealing with panel boards and electrical systems. Electricity can be dangerous, and improper handling can lead to serious injuries or even death. Only qualified and trained personnel should perform electrical work, and they should always follow appropriate safety procedures. Firstly, always de-energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated footwear. Thirdly, never work on electrical equipment in wet or damp conditions. Fourthly, use insulated tools to prevent electrical shock. Fifthly, follow all applicable codes and regulations. Sixthly, if you are not qualified to perform electrical work, hire a qualified electrician. Electrical systems should be inspected regularly to identify potential problems before they lead to failures or safety hazards. Inspection should include checking for loose connections, damaged wiring, and corroded components. Circuit breakers should be tested periodically to ensure they are functioning properly. Any signs of overheating, such as discoloration or melting, should be investigated immediately. Maintenance tasks may include tightening connections, replacing damaged components, and cleaning the electrical equipment. It is important to keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical components, causing them to overheat and fail. Regular cleaning can help to prevent these problems. Electrical fires can be caused by a variety of factors, including overloaded circuits, damaged wiring, and faulty equipment. If an electrical fire occurs, it is important to act quickly to extinguish the fire and prevent it from spreading. Firstly, turn off the power to the affected circuit. Secondly, use a fire extinguisher that is rated for electrical fires. Thirdly, call the fire department. Never use water to extinguish an electrical fire, as water can conduct electricity and increase the risk of electrical shock. Electrical safety training is essential for anyone who works with electrical equipment. Training should cover topics such as electrical hazards, safety procedures, and the use of safety equipment. Employees who receive electrical safety training are more likely to work safely and avoid accidents. In summary, electrical safety is a critical concern that should be taken seriously by everyone. Following appropriate safety procedures, inspecting and maintaining electrical equipment regularly, and providing electrical safety training to employees can help to prevent electrical accidents and injuries.